Hi all, in this video I will explain QuineMcClusky method of minimizing Boolean expression. So this QuineMcClusky method, which is also called tabular method. So usually we perform the simplification using K-map method, but the K-map method is limited to a maximum of 6 variables. So this QuineMcClusky method is more systematic method of minimizing expression of even larger number of variables. So this is suitable for hand computation, as well as we can use it by the machine, that is we can use this for programming. So the fundamental idea is repeated application of the theorem PA plus PA bar is equal to P. We apply this on all the adjacent pair of terms, and this will yield a set of prime implicants and from which a minimal sum is selected. So I will explain how to perform this QuineMcClusky simplification with an example. So the problem is to simplify the term sigma m 1, 2, 3, 5, 6, 7, 8, 9, 12, 13 and 15 by using QuineMcClusky method. So in this case, these are the min terms given. So the first step is we need to list all the min terms. So I'm just listing all the min terms in binary format. So the min terms are 1, that is, since we are considering a variable up to say 50, so we need to represent it in 4-bit. So it will be 0 represents 0, 0, 0, 1, and next min term 2 is 0, 0, 1, 0, and 3, that is 0, 0, 1, 1. Then 5 is 0, 1, 0, 1. Then 6, 0, 1, 1, 0. And 7, that is 0, 1, 1, 1. 8, 1, 0, 0, 0. 9, 1, 0, 0, 1. Then 12, that is 1, 1, 0, 0. Then 13, that is 1, 1, 0, 1, and 15, which is 1, 1, 1, 1. So these are the min terms in our question. Okay. So now we can move to the second step. So the second step is arrange all these min terms in groups of the same number of ones in their binary representation. Okay, that is, we need to group these min terms such a way that each group contain same number of ones. Okay, that means we need to identify the min terms with same number of ones. See, for example, when you consider, see this term, that is 0, 0, 0, 1 and 1, 0, 0, 0. In both these numbers there exists only a single one, this one and this one, right? So we can consider 1 and 8 in same group. So similarly we need to identify all other groups. So I am creating a group. So first 0, that is group 0 I am considering. So in group 0 I am considering the binary representation of this min terms with no 1. So in this case, since 0 is missing here, so all other terms is having a single one, so there exists no element in this group. Okay, so now I am considering the next group. So what will be the next group? Next group will be a group containing only a single one in that number. Okay, so I am considering the first group, that is a single one group. That means when you consider the number 0, 0, 0, 1, that is corresponding to the min term 1, is having only a single one. Then next one, when you consider 2 again having a single one, that is 0, 0, 1, 0, only a single one term. So we can add this to the same group. Then identify the next element. When you consider 0, 0, 1, 1, 2 ones are there, so we cannot include. Then 0 1 0 1, again 2 ones are there, so we cannot include. And the next one will be what? Will be 1 0 0 0, that is having the min time value 8, that is 1 0 0 0, that is its binary representation as only a single 1. Then any other term? No. All other term contain more than one bit. Right. So this will be the first group. Okay. Then I am generating the second group. So second group will be like identify the min time with two one time. Right. So which are the elements? So when you consider the min time 3, it is 0 0 1 1, that means 2 ones are there. So I can add this to this group. So 3 will be in the second group with 2 ones. Then when you consider 5, 0 1 0 1, so again 2 1, so I can include 5 into this group, that is 0 1 0 1. Then next one, when you consider 6, again 2 ones, 0 1 1 0, so again 2 1 time, so 0 1 1 0. Then the next time when you consider 9 is having 2 1, so 1 0 0 1, so 2 1 time, so I am including that to the group. Then again 12. What about 12? 12 is again 1 1 0 0, which is having 2 1 time. So 13 and 15, no. So this will be the second group. Now we can generate the third group. This third group means the group of min times which is having 3 1 bits in that binary representation. Okay, so consider the 3 1 bit. Yeah, when you consider the 7 is having 3 ones in the binary representation, that is it is 0 1 1 1, 3 ones, right? Then any other number? 13. So 13 is 1 1 0 1, which is again 3 ones in the binary representation and no other time. So this will be third group. Now we can consider the next group. In the next group, it will contain what? It will contain the elements with 4 ones. So the last one, that is 15, is having 4 ones. So it will be in the last group. So these are the groups we generated. So this is your second step. Now, so in the next step, we compare each term of the lowest index group with every term in the succeeding group. And when you compare this, we need to perform some operations. That means, suppose for example, first we can compare the first element in the first group with the third element, that is first element in the second group. Okay, so when you compare it, so the first two, we need to compare bit by bit. Okay, so when you compare 1 and 3, the first, that is m must be same, the next bit same, but the next bit, it is 0 here but 1 here, and the LSB again same. That means only a 1 bit change is there. So if there is only a single bit change between the terms in two succeeding group, then we can combine them together by placing a dash symbol on the mismatched position. That means in this case, first two bits are same, only this third bit differ. So we can combine these two, that is I can combine 1 and 3, and when you combine, the same things are the first two bit and difference is for the third bit. So I put a dash here and again the last bit same, so I can write it like this. So what is the procedure? The procedure is I compare the first term in the first group and first term in the second group and identify the bit change. If there is only a single bit change, I can combine these two, that is I can combine 1 and 3 since there exists only a single bit change, and bit change is at this position. So I am just placing a dash symbol here. Okay. So similarly, I need to perform this comparison element by element wise, and when you combine two terms, I need to put a tick mark. Okay, those combining terms, just put a tick mark. Okay, then I need to combine what? Combine the first with fifth element. So when we are trying to combine 1 and 5, what about the number of bit change? So here 1 1 same, 0 0 same, and the next bit here it is 0, but here it is 1, so 1 bit change, and 0 0. Yeah, again when you combine 1 and 5, only a single bit change, so we can combine, that is 1 comma 5. And how we will represent change in the second position? So I can write it like 0 dash 0 1. So I am taking 1 and 5. Okay, then I can combine what? 1 and 6. Try to combine 1 and 6. When you consider 1 and 6, the LSB change and the second bit again change. So there exists more than one bit difference. So we cannot combine these two. So again consider the next combination, that is 1 and 9. So when you consider 1 and 9, is it possible to combine? So LSB same, next bit same, next bit same, only change in the MSB. So only one bit change. So we can combine 1 and 9. So I am combining 1 and 9. Sorry, 1 and 9. How we will combine? Only the MSB change, all other C. Okay. Then identify the next combination. Now we can consider with the second that is 0 0 1 and 12. So when you combine more than one bit difference, so we cannot combine. So we can go for the next element, that is we can take 2 from the first group and again search for the other terms in the second group. So first possibility 2 and 3. So 2 3 when you consider, is it possible to combine? What about the number of bit change? One number of bit change 1 and no changes. So we can combine 2 and 3, that is only the LSB change, that is we can write 0 0 1 dash. So similarly then we can check with the next element when you combine 0 and 5. Sorry, 2 and 5. So when you consider 2 and 5, is it possible to combine? What about the number of bit change? 1 2. So more than one bit change, so we cannot combine. And the next one will be 2 and 6. We can combine. Why? Only one bit change, so we can combine 2 and 6. And what about the expression? It will be 0 dash 1 0. So again we can check with 2 9. So again we cannot combine more than one bit difference. In 2 and 12 also more than one difference. Okay. So then what is the next option? Next option, we take the next element from the first group and again compare with all other terms in the second group. So follow the same procedure. You will get 8 and 9 with 1 0 0 dash, and then we will get 8 and 12 with 1 dash 0 0. Okay, so this will be your next group. So that is after combining these two, you will get a new group. So this will be the next group in the next level. So now we need to identify the next group. The next group is generated by combining these two groups. Okay, group 2 and 3. So compare group 2 and 3 and apply the same procedure. You will get what? You will get next group. So same procedure, take 3 and 7. So 3 and 7. How many bit change? Only a single bit change in the second position. So we can combine these two. So 3 comma 7 we can combine, and whenever you combine you just put a tick mark. Okay, 3 comma 7 we can combine and bit change in the second position, so it will be 0 dash 1 1. Similarly, identify all other terms. So it will be 5 comma 7 with 0 1 dash 1, then 5 comma 13 with dash 1 0 1, and then 6 comma 7 with 0 1 1 dash, and then 9 comma 13 with 1 dash 0 1, and 12 comma 13 with 1 1 0 dash. Okay, so you combine the second group and third group in the previous level, so you will get the next group. Then what will be the next step? The next step is combine the last two groups, that is group number 3 and 4. So when you combine group number 3 and 4, how you will get? So you will get 7 and 50. 7 and 50 only one bit change. So we can combine 7 and 15, and it will be dash 1 1 1. And what about 13 and 15? 13 and 15 again only one change, one bit change. So 13 and 50 we can combine, and the bit change is 1 1 dash 1. Okay, so this will be the second level. So in the next step we can follow the same procedure. Again we will combine, that is we will compare the adjacent group and combine the terms with a single bit change. Okay, so again perform the same procedure. So when you combine this, that is the first element is 1 comma 3, and we can check with 3 comma 7 and identify the number of bit difference. So when you compare these two, what about the number difference? One bit change, second bit change, so more than one bit difference, so we cannot combine. Then again check with 1 3 and 5 7, so the LSB same, the next bit same, and one difference, and the last bit same, so we can combine 1 3 and 5 7. Okay, so I am combining this two. This will generate a new group. So 1 3 5 7, and we can write it similar to the previous case. So just put a dash symbol on the different bit. That is, it will be 0 dash dash 1. So I am combining 1 3 and 3 7. So 5 7. Okay. Then again compare 1 3 and 5 13. So when you compare, again we cannot combine more than one bit difference. So similarly identify all other combining terms. So I will write the combinations. It will be 1 5 9 3, so 9 13 with dash dash 0 1, and then it will be 2 3 6 7, that is 2 3 6 7 with 0 dash 1 dash, and then next possibility 8 9 12 30, that is 8 9 and 12 30 with 1 dash 0 dash. Okay, so you will get the first next group, and then we can compare the next two groups. When you're combining next two groups, you will get 5 7 13 15 with dash 1 dash 1, and we already take 1 9, then we take 2 6, and 8 12 is also there, then 5 13 is there, then yes, 7, this is 7 7 15 is there, so 13 15 is in there, so we took all the mintimes. Okay, so again we can perform the same thing. So when you try to combine this, you won't get any matching. Okay, so this will be the final grouping. So the next step is you need to mark all the terms without a tick mark. So we are not taking all these terms to the next level, so we are considering this as different terms. I am calling this as P, this will be Q, R, S and T. So these will be your prime implicants. These will be your prime implicants. Okay, so from these expressions we will identify the essential prime implicants and we will write the expression for it. So when you consider P, so what will be P? How we can write P? It is dash 1 dash 1. Okay, so that means this represents, say, if the expression, if it is a 3 variable A, B, C, D, so how you will write? So this dash represent A, this will be B, C and D. So how we can write P? So P can be written as what? B, D. B and D, one take. And what about Q? Q will be 1 dash 0 dash. So 1 is A, then B absent, C is 0. So we can write it as AC bar. Then R is A is 0. So A bar, B absent, C, D absent. Similarly, what about S? S is equal to blank blank 0 1, that is C bar D. And what about T? T is A bar, B, C absent, D. So these are your prime implicants. So now the next step is, based on the prime implicants, we need to generate a prime implicant chart. So our prime implicants are P is equal to BD, then Q is A bar, AC bar, then R, A bar, C and S, C bar D, and T is A bar D. So these are our prime implicants. Then the next step is we need to generate a prime implicant chart. That is, this is used to show the relationship between the prime implicants and the min terms. So we need to create a table where the rows indicates the number of the prime implicants and the column indicates the min terms. See example, in our case we can write the prime implicants. So we consider the prime implicants, that is P, which is equal to BD, that is generated 5, combining the min terms 5 7 13 15. Then Q is your 8 9 12 13. This is from the previous table. That is R is actually 2 3 6 7, and S 1, 5, 9, 13, and T is 1, 3, 5, 7. Right. So these are the prime implicants. So then that will be each row. Then we need to create columns. So in the column actually we create the min terms. That is, which are the min terms? The min terms are 1, 2, then 3, 5, 6, 7, 8, 9, 12, 13 and 15. So just create a table like this. So these are the min terms in our question. Okay. Then just put a cross mark on the corresponding min terms for each prime implicant. So the P prime implicant consists of 5, 7, 13 and 15 min terms. So just put it cross mark. So 5, 7, 13 and 15. Then Q consists of 8, 9, 12 and 13. Then R is 2, 3, 6 and 7. Then S 1, 5, 9, 13. Then T 1, 3, 5 and 7. Okay, just identify the min term corresponding to each prime implicants. So in P 5, 7, 13, 15, 5, 7, 13, 15, we just put a cross mark. Okay, then the next step, identify the min term with a single cross mark. Okay, so when you consider this first min term, there exists 2 crosses on the first column, so no need to consider. So consider the second min term only a single cross, so we need to consider this. Then consider third one again 2, 5, 1, 2, 3 cross, again 6, yeah, only one, so we can just mark that. Then 7 again more than one, 8, yes, only a single one, so we need to consider. Then 9 more than 1 and 12 again only a single one, you need to mark it. Then 13 more than 1 and 15 there is only a single one, so you mark it. Then identify the min terms, the prime implicants corresponding to the circle crosses. So this corresponding to P, and this circle corresponding to Q, and this correspond to R, and okay. Okay, so these ticked one are essential prime implicants. That is P, Q and R are essential prime implicants which should be there in the simplified form. So the essential prime implicants are P, Q and R. Now consider this P, Q and R. So these are the essential prime implicants which will be there in your simplified form, so that you can write the simplified form as P plus Q plus R. Okay, suppose this is F, we can write F is equal to P plus Q plus R. Then again from this P, Q and R is all the min terms covered. See, consider P, Q and R. P cover 5, 7, 13 and 15. Q covers 8, 9, 12 and 13. R covers 2, 3, 6 and 7. And what is the remaining one? The remaining one is this one min term. So we need to include this min term 1. So how we can include this min term? By using which prime implicants we can include this one? We can include this one either using S or T. See, in both the case S and T, the min term 1 is available. So PQR are the essential one, which is very essential to R to the result, and consider s and t, either you can add s or t to include the remaining mean time 1. So we can write it as p plus q plus r plus s, or we can write the expression as p plus q plus r plus t. Okay, so what is p plus q plus r plus s? So p corresponding to bd plus q corresponding to a c bar plus r is a bar c plus s is c bar d, or the expression will be bd plus ac bar plus a bar c plus what will be t? T is a bar d, a bar d. So both these are possible answers. Okay, so these are the two possibilities. Either the simplified form can be write a bd plus a c bar plus a bar c plus c bar d, or we can consider bd plus a c bar plus a bar c plus a bar d. Both are correct answer for the simplified expression for the function f.